Okay, so you might want to realize how this works, because then I'm going to ask you to derive something different. It's going to work very, very similar. So we're looking at inverse trig derivatives. Now I'm going to give you all the derivatives. I'm going to show you what they look like, but and give them to you, then we'll show you how they work. But I do want you to go through and be able to derive a couple of them, so you see they're not just made up out of thin air. So we're going to derive the, now where do I always start when I derive derivatives?
The definition.
Definition derivatives. So we start off with the limit as delta x approaches 0 of the inverse sine of x plus delta x minus the inverse sine of x all over delta x. And then we step back from that, we're like going, oh my goodness, you know what? In my pre-calc class, we did the sine of a plus b, right?
Yeah.
We did the sine, we did the sum and difference identities, but we never did identities dealing with inverse sine.
We didn't.
We didn't.
Okay.
Yeah. And I'm not so sure there's any good ones to look at. So we're going to have to solve this one a little bit differently. Let's use this one using the derivative rules. Okay? So here we go. I'll start off with the proof. It's going to start off with y equals inverse sine of x. Okay? Now we're assuming that the domain is correct. You know, the sign that the x value is between -1 and 1. Because if it's not between -1 and 1, then there is no inverse sine and there is no derivative. So we're assuming x is somewhere between those two values. How would I solve this particular one? So first, what I would do is, how do I get rid of inverse sine?
Cosine.
No.
Bring it to the front.
Say it again.
Bring it to the front.
No.
Oh,
What's the inverse of inverse sine?
sine.
Sine. So let's take the sine of both sides. The sine of y is going to equal the sine of the inverse sine of x. Okay. So in number 2, this side stays the same. We just have the sine of y, which do I know the sine? Do I know the derivative of sine?
Yeah.
Do I know the derivative of y?
Yeah.
Yes. So this side is going to work out perfect. What happens on this side? What does sine and inverse sine do to each other?
They cancel.
They cancel out, and I'm left with just x. Do I know the derivative of x?
Yeah.
Beautiful. Let's go ahead and do the derivative. And we call it implicit differentiation. This is the reason why this is 3.8, and we did implicit in 3.7. Okay? What is the derivative of the sine of y?
Cosine of y.
Cosine of y. And Maya, I may have cut you off. Were you going to say something else after that?
Does it have the dy dx after?
Why would it have that?
Because it's got a y.
Correct. It's got the inside. You have to do the inside. So implicit tells me that's going to be cosine y dy dx equals, what's the derivative of x?
1.
So then, in step 4, I'm going to have dy dx is going to be equal to 1 over the cosine of y. Now that's kind of ugly. We don't like that. So we're not going to keep 1 over the cosine. We're going to change it. So do you remember way back in pre-calc, and Ellie has a huge advantage because she's been A+ in pre-calc, and has, so you can always refer to her if you don't remember. But does anyone remember what is the sine squared of y plus the cosine squared of y equal to?
1.
1. Now I see cosine of y and I see cosine squared. So let's see if we can solve. We'll go cosine squared of y is going to equal 1 minus sine squared of y. And then how do I get cosine by itself? Not divide.
Square root.
Square root. So then I'm going to have the cosine of y is going to be equal to the square root of 1 minus sine squared of y. Okay? So cosine of y can be replaced with
Square root 1 minus square root of y.
Okay. So we're going to number 5. And I'm going to say dy dx is going to be equal to the square root. I'm sorry, it's going to be 1 over. My bad. 1 divided by the square root of 1 minus sine squared of y. Now, if I'm going to leave sine squared in my answer, I could have just left cosine. Would you agree? So I got to get rid of the sine somehow. So what can I substitute in the place of sine? The sine of y equals what? Equals x. So then, number 6, dy dx is going to be equal to 1 over the square root of 1 minus x squared. And there's my proof. There's my result. So when you have inverse sine, its derivative is 1 over the square root of 1 minus x squared.
Where did the sign go?
What is sine of y? Sine of y is x. So I replaced sine of y at squared with x squared. Because if you're going to leave a trig function, you might as well have just left this one. So we can't leave a trig function.
Yeah.
Now we have it in terms of its argument. Other questions?
Just need to write it down.
Yep.
So if we have to write this on a quiz or
You won't.
test,
Okay.
do we have to write the sine squared plus cosine squared y equals 1?
No, I just showed you where I got it from. And you don't have to write the, well, you'd already write this one. Now on the test, I'm not going to do it for you in class. So if you want to try it later with friends, you're welcome to. But on the, it's actually not the test, it's going to be on a quiz between now and the end of the semester, end of the unit. I am going to say, please derive for me the inverse cosine. Okay? Same concept, same process, except rather than sine, we have cosine, and so forth. Make the same substitutions. Okay. All right, let's see how it works now. Okay, are we good? Yes.
Is the cosine squared, cosine y squared equals negative sine y squared? Is that like just a identity that we should know?
This one here?
Yeah.
Well, sine squared plus cosine squared equals 1. So if you just subtract sine squared, it's 1 minus, that's a 1.
Yeah.
1 minus sine squared of y. Yeah. That goes back to that Pythagorean identity. Yes?
So what is this proving again?
We're deriving the derivative of inverse sine.
Finding?
Deriving.
Is it the same thing in this case?
As what?
Deriving and finding?
No.
Uh,
We already know what it is. Well, you can look it up. I've got all of them right here. We know what it is. We're not finding it. We're just deriving it. We're showing how we got it. Showing the path of how it came to be. Good questions.
that
We
sounds
good?
like proof, yeah.
All right. So you will find a question that says something like, find dy dx of, and let's go with inverse sine of, let's say, 2x squared plus 3. Okay? Find the derivative of inverse sine 2x squared plus 3. All right? So what rule are we going to use? Besides the inverse sine rule, what are we going to use? Chain rule. Very good. So what's the inside of my chain?
2x squared plus 3.
A equals 2x squared plus 3. So then dA dx will be what?
4x.
Sorry, I started writing right away, giving you a chance to write it down. And correct, it's 4x.
Yeah. Decent.
What's the outside function?
Sine.
Inverse sine.
Negative sine.
Inverse sine of A. And this is where our new derivative steps in.
Would it just be 1 over square root of 1 minus x squared?
1 over the square root of 1 minus A squared. That's exactly it.
Yeah.
So then my answer I simply have 4x times And I'm gonna rewrite the dy dA, but what substitution do I make?
You plug in A.
Instead of a, I'm gonna put in what a equals.
Yeah.
So it's 1 over the square root of 1 minus 2x squared plus 3 squared. And if you want to, you could write it as 4x over and if you want to, you can do the algebra and square it out and simplify, and I wouldn't. Here, or if you want to put the 4x on top, that would.
Yay.
So my point today was deriving the inverse sign, which we did. Does it make sense how we apply it?
Yeah.
It really is just the same as the chain rule, you're just plugging in. Okay. All right, then, on a separate sheet of paper, on a cheat sheet, or if you have a reference sheet, I'm gonna give you all 6 of them, okay? So we know the first one. We know that the derivative of the inverse sine of x is going to be equal to 1 over the square root of 1 minus x squared. Does anyone have a guess on what they think the derivative of cosine would be? The derivative of inverse cosine of x.
1 over square root 1 plus x squared.
That's a great guess. It's wrong.
Oh.
Because later I'm going to ask you to derive it, so you might as well know what the answer is before you start. Any other guesses on what it might be?
Would it be minus that?
Yes. It'd be -1 over the square root of 1 minus x squared.
Is it because like cosine is like just negative sign?
Correct. Just because of that one little negative change, everything else is the same. All right, I'm going to give you the derivative. Which one do you want next?
Tangent.
You want tangent next? I really wasn't going to tangent next. Oh, I was actually. Tangent inverse of x. 1 over 1 plus x squared. So it's kind of like the top one without the radical and a plus. Anyone have a guess on what you think the derivative of cotangent inverse would be?
-1 over 1 plus x squared.
-1 over 1 plus x squared.
Would that one just be the square root of 1 minus x squared over 1?
1 over the absolute value of x times the square root of x squared minus 1.
Is that supposed to be inverse?
Inverse. So 1 over the absolute value of x, square root of x squared minus 1. But once again, you can derive these going back to the same way we did sine. Cool. So what's going to be the other one?
-1 over the absolute value of x radical x squared minus 1.
Wouldn't that be easy if it was?
Yeah.
If it was just the negative of that one, that would make life so much easier.
What?
It is.
Yeah.
The co's are just the negatives of the regular ones. Yep. Makes life easier. Now, would you like to know the good news?
Yeah.
Are you leaving? Yep. Bruce is leaving.
Bye.
That's not the good news.
He's
The
not
good
even-
news is,
Goodbye.
these will never be on a non-calculated portion of a test. Therefore, you would never have to have these memorized.
Yay.
Okay? You're welcome.
Yeah.
But you do need to know how to use them, and you do need to have them for reference.
Okay.
So I might give you a reference sheet on a calculated portion of the test that would have these on there.
Yay.
I would never actually make you memorize these. There's no point in doing that. Okay? The regular ones, the trig functions, yes. Inverse trigs, no.
Bye, buddy.
Even AP doesn't make it too
Bye.
bye.
So wait, we have a quiz this Friday and then the test next Friday?
Quiz this Friday?
Yeah, is it
What?
this Friday or Monday?
I wasn't gonna do one Friday, but I can do one.
Oh,
No.
You're good.
No.
I thought I said I was gonna have it before the
I'm
end of the
busy this week.
End of the evening?
test.
Before next week's test?
Don't we have?
Yeah, I gotta go through my lesson plans this weekend, so I what test is gonna be. I wanted to do it before Thanksgiving.
Will it be a quiz or
kind
an
of
exam?
No,
Say again?
Will it be a quiz or an exam?
He didn't know.
Well, we're gonna have a quiz prior to chapter 3 test.
Okay.
But I'm looking, we still have 3.9, the logs to do. So, we'll see when the test is gonna be. I was planning on doing it that Friday and then the last day of school before Thanksgiving. We may have to push it till after Thanksgiving. We'll see.
Okay.
I'm not advocating for a quiz this week, I was just trying to.
I'd be glad to give you one Friday, because I'm not gonna be here Friday.
I'm okay.
You're not here. It's this Friday?
We'll be here Thursday or Friday.
No, but Oscar, if he's, no, working.
Okay, here you go, try one. Before I turn you loose on homework, try one example. Now remember, no other rules are thrown out. We still have the product rule, we still have the chain rule, we still have the quotient rule. We could do any of those inside of this. So let's try one. Let's do inverse secant of 6x to the fifth plus 7. 6x to the fifth plus 7.
Oh, what is it?
Find the derivative. You got it? So what's the DA?
30x.
30x, 4.
30x to the 4.
4.
Okay. And what is DY?
1 over absolute value.
Secant, inverse secant of A. No, that's why.
It's x squared minus 1.
So in this case, A squared.
X squared.
Go using X. Yep. Okay. So then, derivative, secant to the negative first. 7 be equal to, I had this discussion with a couple, does it matter which one will goes first?
No.
No, in fact, I know on this one, if I do this one times that, the 30x to the fourth can just go on top. So I'm just gonna write 30x to the fourth over the absolute value of
6x to the fifth plus 7.
times the square root of,
6x to the fifth plus 7 minus 1.
Squared.
there's your answer. Questions?
No.
You good?
Yeah.
Not yet.
Am I good? No. Do I understand it? Yes.
Say it again.
Am I good? No. Do I understand it?
All right, well, I'm done. That's 3.8.
Alright.
Knowing those 6.
Have a good day, son.
I'll leave them up here for those of you who didn't quite get them all written down.
30.
Be glad to help you with any part of homework. You have about 25 minutes.
Wait, how did you do 24?
I got a picture of myself. Okay, do you want me to explain myself? One of the guys.
Okay, now this one could mean that it probably would, or it could mean that necessarily would be better if it were. I interpreted it as it would be better to humanity rather than transnational corporations. It would be better. That's how I interpreted it. So you could agree. Yeah.
Okay, Ross, that's not a good start.
I would